Describe the various techniques for selecting specific portions of your dataset. There are several techniques for selecting specific portions of a dataset, each useful in different scenarios depending on the goal of your analysis. 1. By row and column numbers, you can select data based on its position in the dataset. This is often called indexing. For example, selecting the first 5 rows or columns 3 to 7. 2. By condition, this involves filtering data based on a specific condition. For example, you can select all rows where the value in a particular column exceeds a certain threshold. 3. By column names, if you know the names of the columns you're interested in, you can select these directly. This is very common when you only need a subset of the available data for analysis. 4. Logical indexing. This technique uses true-false conditions to select data. If the condition is true for a row, that row is included in the output. 5. Random sampling. When you need a random subset of your data, perhaps for testing or validation purposes, random sampling allows you to select rows or columns at random. 6. Using functions. Many data analysis libraries and software have built-in functions to help with data subletting. For example, the filter function in R and the .loc, .iloc, and .query methods in Pandas, Python offer powerful ways to subset data based on various criteria. What distinguishes a two-way relative frequency table from a two-way frequency table, and what exactly is the former? A two-way relative frequency table presents the proportion or percentage of each intersection of categorical variables relative to the total number of observations, showing relationships between two categorical variables in a way that makes it easy to see proportions. Each cell in the table shows the relative frequency, which is the frequency of the cell divided by the total number of observations, often expressed as a percentage. In contrast, a two-way frequency table, also known as a contingency table, displays the raw counts of frequencies of combinations of categorical variables. It shows how many times each combination occurs without providing direct insight into the proportions these counts represent out of the total. The main difference between the two lies in what they emphasize. Two-way frequency tables focus on the count of occurrences, while two-way relative frequency tables highlight the proportion or percentage of the total each occurrence represents, offering a more normalized view that can be easier to compare across categories with different total counts. What advantages do two-way frequency tables offer? Two-way frequency tables offer several advantages, particularly in the analysis of data involving two categorical variables. These benefits include 1. Simplicity and clarity. They organize counts clearly, making it easy to see the number of occurrences for combinations of categories at a glance. 2. Comparison. They facilitate the comparison between categories, allowing for a straightforward understanding of relationships and interactions between two variables. 3. Pattern recognition. Two-way frequency tables help in identifying patterns, trends, and anomalies within the data, which might not be apparent in a list of raw data points. 4. Basis for further analysis. They serve as a foundational tool for more complex statistical analysis, such as calculating probabilities, performing chi-square tests for independence, or assessing associations between variables. 5. Facilitating decision-making. By providing a clear view of the data distribution across categories, these tables support informed decision-making in areas like market research, policy planning, and resource allocation. 6. Efficiency. They make it possible to process and understand large amounts of data quickly, without the need for sophisticated statistical software. Describe 5 scenarios from everyday life where selecting specific portions of data is beneficial. 1. Healthcare patient management. In a hospital's patient database, doctors might subset data to view records of patients with a specific condition, like diabetes, to tailor treatment plans or monitor the efficacy of interventions. This targeted approach helps in managing and improving patient care efficiently. 2. Retail inventory control. A retail manager might use subsetting to analyze sales data for specific product categories during a certain time frame, like holiday seasons. This enables them to adjust inventory levels, plan marketing strategies, and decide on discounts for overstocked items to optimize sales and reduce losses. 3. Educational research. Researchers studying educational trends might subset data to focus on the performance of students from different demographics, such as comparing test scores across various socioeconomic backgrounds. This can highlight achievement gaps and inform targeted educational intervention. For financial analysis, financial analysts often subset data to examine the performance of specific sectors or stocks within a particular period. This allows them to make informed investment decisions, forecast trends, and advise clients on portfolio adjustments to maximize returns or minimize risk. 5. Marketing campaigns. Marketers might subset customer data to identify specific groups based on purchasing behavior, preferences, or demographics. This enables them to create personalized marketing campaigns, improving customer engagement and increasing the effectiveness of advertising efforts.